Okay, to start the year off, we're going to review the scientific method. And we're going to start off with kind of doing a little bit of history about why the scientific method is important to use. So we're going to kind of go back in time and figure out how people thousands of years ago how they used to make hypotheses or inferences based on observations and what happens when you don't use the scientific method. So, don't this is not part of the actual Cornell notes, so this part does not go actually in your notebook. This is just kind of an introduction to why we use the scientific method. Okay, so an observation. A good scientist is observant and notices things in the world around him or herself. Anything you can see, taste, touch, hear, or smell is an observation using your five senses. For centuries, people based their beliefs on their interpretation of what they saw going on in the world around them, without testing their ideas to determine the validity of these theories. In other words, they didn't use the scientific method to arrive at answers to their questions. Rather, their conclusions were based on untested observations. Among these ideas, since at least the time of Aristotle, 4th century BC, people, including scientists, believed that simple living organisms could come into being by spontaneous generation. This was the idea that non-living objects can give rise to living organisms. It was common knowledge that simple organisms like worms, beetles, frogs, and salamanders could come from dust, mud, etc., and food left out, quickly swarmed with life. For example, observation 1. Every year in the spring, the Nile River flooded areas of Egypt along the river, leaving behind nutrient-rich mud that enabled the people to grow that year's crop of food. However, along with the muddy soil, large numbers of frogs appeared that weren't around in drier times. Now, back then, people did not follow the scientific method, so instead of making a hypothesis, they actually formed what's called an inference. An inference is a prediction that is not tested. So you guys know whenever we make hypotheses, we test them, we do an experiment. Well, they would just see an observation and they would make an inference, but they wouldn't test it, so it's not called a hypothesis. So, based on that observation, people thought that frogs come from mud. That's what they were able to infer based on the observation, because the frogs were only around when there was muddy soil. They were not around during drier times. So they made the inference, frogs come from mud. And because they never tested that, that's what they really believed. So let's do another example. In many parts of Europe, medieval farmers stored grains in barns with thatched roofs, like in Shakespeare's house. As a roof aged, it was not uncommon for it to start leaking. This could cause spoiled or moldy grain, and of course, there were lots of mice around. So, what do you think they thought? Where do you think they thought the mice came from? They thought the mice come from moldy grain. And because, again, they never tested that inference, it didn't become a hypothesis, and that's just what they thought. And of course, they were wrong. Let's do another example. In cities, there were no sewers or garbage trucks. Yuck. Sewage flowed in the gutters along the streets and sidewalks. And so the sidewalks were raised above the streets to give people a place to walk. In the intersections, raised stepping stones were strategically placed to allow pedestrians to cross the intersection, yet were spaced such that carriage wheels could pass between them. In the morning, the contents of the chamber pots were tossed out the nearest window. When people were done eating a meal, the bones were tossed out the window too. A chivalrous gentleman always walked closest to the street when escorting a woman, so if a horse and carriage came by and splashed up this filth, it would land on him and not the lady's expensive silk gown. That is so nice. Boys, take notes. Most of these cities also had a major rat problem, which contributed to the spread of the bubonic plague, also known as Black Death. Hence the story of the Pied Pipers. So, Aren't you really glad that we have plumbing? I know I am. So where do most of these people, where did they think that the rats came from? Because they never did any testing. They just made an observation and an inference. Okay, these people thought that rats come from sewage. Okay, and it stayed an inference because they never tested it. And that's really what people thought back then, because they only saw rats when there was sewage around, not knowing that the rats fed off all that uneaten stuff in the streets, which is really gross. Okay, last example. Since there were no refrigerators, the mandatory daily trip to the butcher shop, especially in the summer, meant battling the flies around the carcasses. Typically, carcasses, which is just meat hung up, were hung up by their heels, and customers selected which chunk the butcher would carve off for them. They actually still do that in Brazil. I saw that. They had meat just hanging up from ceilings. It was a little disturbing because the meat would turn green, and I did not want to eat a lot of their meat that was cooked there. That was a long time ago, though. So where do you think these people thought the flies came from? Well, they thought flies come from meat. And because they never did any testing, it wasn't a hypothesis, because it can't be a hypothesis unless you test it. They just made inferences off observations, and that's what they thought. So, as you can see, it's really important to test your predictions to see if it's supported or not supported. So now let's get into our notes. Our essential question for today is, what are the steps of the scientific method? The targets, we actually are going to cover 3 targets today. Target 1, 2, and 3. Identify and apply all the steps of the scientific method. We should be very proficient at this right now. Be able to identify in an experiment the independent, dependent variable, control, constants, and be able to create a graph using independent and dependent variables. And you should also be able to evaluate whether an experiment is valid or not. Oh, wrong one. Okay, so the first part of the scientific method is a question. So we're going to start with that last observation that we read about the flies. So we're going to start off with the question, where do the flies at the butcher shop really come from? Does rotting meat turn into or produce the flies? Now, we're going to write a hypothesis, which is a tentative answer to the question, a testable explanation for what was observed. The scientist tries to explain what caused what is observed. It's a hypothesis only if we test it. So, we're going to write a hypothesis. Now remember, we always start off with I think. Flies come from other flies because, don't abbreviate like I did, this is just for shorthand notes, because that's how living things reproduce. Okay, so we're just going to come up with a general hypothesis and see if it's supported or not. Now, remember, the other people thought that flies don't come from other flies. They thought that flies come from meat. So I think flies come from meat because flies are always around meat. So that's what they thought. They thought that flies really came from meat. Now, we're going to test this. So if we test this, then we can find out and see if that hypothesis is supported or not. So we're going to perform an experiment. An experiment uses procedures to test a hypothesis. Sometimes you guys have to write the procedures of an experiment. Sometimes I give them to you. Before we start an experiment, we have to identify the independent, dependent, and constants. So remember, the independent variable is the variable that changes in a lab. So, and we only change one variable. Only one variable changes. Make sure you write that down. Okay, so the independent variable is the variable that changes, and we only change one variable that changes. Okay, that's our independent variable. The dependent variable is the variable that we measure. and it depends on the independent variable. So whatever the independent variable is, we have some way to measure how that changes. Okay, constants are things that stay the same, so we only change one variable. Then the last part, the control, is the standard to which the outcome of the test is controlled. It's our standard of comparison. It is one of the independent variables. So one of the independent variables is a control experiment. Okay? So let's take a look at the experiment if we were to test whether flies come from meat. So we've got 3 flasks. Inside the flask are 3 pieces of meat. And then there's flies around. And if you notice about the 3 flasks, we have 1 flask that's closed and then 2 that are open. Okay, so let's go back and let's identify our variables. Variable is independent variable, the variable that changes. So in this experiment, the variable that changes is closed versus open flask. The dependent variable, we're going to measure whether or not flies come from meat. So we're going to count the number of flies that are around the meat to see if they come from meat. Now, the constants are things that are kept the same. So if you notice, each piece of meat is the same size. The container, the flasks are all the same size. So those are all constants, and it's probably the same type of meat. Now the control is the standard for comparison. So we left these flasks open because we thought flies came from the meat. So the flask that's closed is actually your control because that's the one we're going to compare the ones that are open to, the closed container. So the closed container is the control. So then after we perform our experiment, we analyze the data. We collect data and record what's happened during the experiment. Data can be in the form of graphs like a bar, pie, or a line graph. Data can either be qualitative or quantitative. Qualitative is data that deals with words or letters. Think of letters as qualitative. Qualitative has an L. Quantitative is the data that we deal with most. This is data that has numbers. So whenever we use numbers for data that's quantitative, think of quantitative as quantity. Now, when we graph data, okay, we always, and we did this last year, when we graph our data, if this is a graph, okay, we're going to draw a graph a little bit, okay, the dependent variable, the variable that we measure, always goes on the y-axis, because that is where your scale is. So that is where the dependent variable goes. Then on the x-axis of a graph, that is where our independent variable goes. And then don't forget, we always need to have a title for our data or for our graph. And remember, on the dependent variable, if there's units that go with those numbers, you need to make sure you put those units. Okay, if you ever have to create a data table, when you create a data table, let me put one in there real quick. Okay, when you create a data table, there's a real easy way to remember how to make one. When you create that data table, the independent variable always goes in this first column. That's what you change. Your dependent variable always goes in the next box next to the independent variable. So this is the area where your dependent variable goes. Now remember, whenever we do an experiment, we always have more than one trial, and that way we have more accurate data and we decrease errors. So usually your dependent variable has more than one trial, and then we usually always have to take an average of those trials. So we usually have at least 3 trials, and then we always want to make sure we take an average in this last trial, in this last box. That's in order to create more accurate results for our experiment. So remember, we never just want to test something once. We want to test it more than once. And then after you've got your data table and you've created a graph off your data table, you then get to form a conclusion off your data. So a conclusion is a logical answer to the question. based on data and observation. So in your conclusion, we do 5 things. We restate our hypothesis. So remember, our hypothesis was that I think that flies come from meat because I always see flies around meat. That's what people used to think. Now, let's take a look at our data. Let's see if it supports that or not. So right now we would fill out the meat. Okay, just meat by itself. Does it have any flies? It does not. So we would record the flask that was closed had no flies. The flasks that were open, the meat had flies because flies were allowed to come in through the flask. So if you look at the meat, does the meat that's closed automatically create flies? It does not. So if we go back down to our conclusion, we would write that my data does not support my hypothesis because flies do not come from meat. Okay, now this is pretty important. Sometimes we like to reverse this and say my hypothesis supported my data, but just think about it. It's always your data that has to support or not support your hypothesis, because that's what we're doing the experiment. That's what we're collecting, is that data to see if your guess was correct or not. Okay, so please make sure you put my data first, either does or does not support my hypothesis. And then what I learned is always something new that you've learned, either from the notes or from the lab or from your practice activities. And then here's the big one that we need to make sure we remember on real world importance. We want to put down why it's important to study the scientific method, whatever our target is. Today our target is the scientific method. We want to say why it's important. So we could put the scientific method. Let me type this in and then. Okay, so when we talk about the real world importance, okay, we need to tell why it's important to learn about our target. So the scientific method is important because without testing our hypothesis, we will not know if our prediction is supported. And then the last part, you always want to come up with a new question about your target. So my new question would be, how do students from other countries write up a lab report? Do they have similar lab reports as we do? Okay, then you could maybe go out and find that out. So those are all the steps of the scientific method, and hopefully you've got a better understanding on why it's so important to use the scientific method, because according to what other people used to believe before they tested their hypothesis, they believed some pretty silly things.